So the general solution form yx for the higher order ODE is consult with the homogeneous solution plus the particular solution. So yhx plus ypx. And how we get the homogeneous solutions? For the yhx is called homogeneous solution. A homogeneous solution usually have an arbitrary constant when you solve the homogeneous solutions. And to get the homogeneous solutions, we are trying to solve the higher order ODE yn plus p n minus 1 x y n minus 1 prime plus dot 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 p1 x y prime plus p0 x y, that is equals to 0. So when the forcing function is 0, we call it, to solve this higher order ODE, that is the homogeneous solution, which will contains an arbitrary constant. And for the ypx, that is called particular solution, which usually don't have an arbitrary constant. And to solve these particular solutions, we will include the forcing functions to solve the particular solution. So it's yn plus pn minus 1x, yn minus 1 plus dot 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 p1x y prime plus p0x y equals to forcing function. So for the forcing function is now to 0, then we can get the particular solutions which usually don't contain that an arbitrary constant. And to get the general solutions by x, so this is the general solution by x, that is usually put these two solutions together. And there is another terminology called unique solution. What is unique solutions? So basically for homogeneous solution, you will get this arbitrary constant. You don't know what that is, the constant. And to generate the unique solutions, you will apply different conditions, whether that is initial value problem conditions or that is the boundary value conditions. You can change those arbitrary constants by using those conditions to get these unique solutions. So that is generated by specifying unique conditions that must be satisfied. Thereby identifying the arbitrary constant, an arbitrary constant within the homogeneous solutions. So those arbitrary constants can be identified using the conditions, the unique conditions. And these conditions can be, so define arbitrary values. We can use either IVP. So it stands for initial value problem. It stands for initial value problem. Initial value problem. That means you define these n arbitrary values by passing the initial point. Okay? Define n arbitrary value passing initial points. There is another way to define this n arbitrary values using n conditions. It's called BVP. It's a boundary value problem. So instead of only passing the initial points, we will pass one or more points. So define n arbitrary values passing two or more points. And we will talk more detailedly regarding the IVP and the BVP in the later lectures, okay?